This is the second video in a two-part series on factoring trinomials. If you watched the first one, you probably noticed that we kept things pretty easy by avoiding negative numbers. Well, we can do that no longer. So today, it's very, very similar to the first video, the techniques and so forth, and the problems that we explore are similar. What's different is today we have to learn to deal with negative numbers. So now, remember, if you multiply positive times positive, which I think you probably started doing in the, when you were 9 years old or something, you get a positive answer. If you multiply positive times negative, in either order, doesn't matter which comes first, and it doesn't matter which one, is bigger in absolute value. Positive times negative and negative times positive come out negative. So if you're multiplying things that have mixed signs, just two numbers, you'll get a negative answer every time. There is another way to get a positive answer, though. You may recall that negative times negative makes positive. Now, every problem where you're trying to factor and you see negatives anywhere, okay, you're going to need some negative numbers. The question is, how many of the numbers are going to be negative? And you have to start thinking that way for the very start of every problem. So much for introductions. Let's take a look at this first problem. In the previous video, we learned how to come up with a list of things that multiply to make 20. I'll go over that again today, but for now, it's 1 times 20, 2 times 10, and 4 times 5. If you're going to use positive whole numbers, that's it. That's the list. But if you look over here, there's negative 12 in the middle, and that means somewhere over here we'll have to have negatives. Well, before you go picking which side to put the negatives on, the little side or the big side, okay, don't forget you have to make positive 20. The only way you're going to make positive 20 is either positive times positive or negative times negative. And for that reason, we're going to sprinkle negatives all over the place, left side and right. For this problem, it's not good enough to put them on just one side. You have to put them on both sides. And then shift to addition. These multiply to make 20, but if I were adding them, I'd get negative 21. These multiply to make positive 20, but if I were adding them, I'd get negative 9. Yeah, well, so this is the correct combination here, because negative 2 times negative 10 makes 20, but negative 2 plus negative 10 makes negative 12. So this factors as x minus 2 times x minus 10. The other thing we did in the first video is show you a method for checking your work. I'm going to do that again right now to confirm that these are the correct numbers, and I'm going to show you why they help to make both this 20 and this negative 12. So when you're checking your work, you are distributing with this x over to this x, and you're going to do that one more time, x times negative 10, before you are done with this x. Then you're going to multiply with 2, negative 2 times x, and then you're going to multiply negative 2 times negative 10. But that's where the positive 20 comes from. But in the middle, these two terms combine to make the negative 12. So quite literally, I needed numbers that would do two things. They needed to multiply to make 20, like they do right here, but they need to add to make negative 12, like they do right here. Okay? Now, this one has got a 30, and it's positive, but the middle number is negative. So really the reasoning behind what I'm going to do here is exactly like problem 1. I'm going to come up with a list of numbers that multiply to make 30, and this is the end of that list unless you're going to allow negative numbers. Well, you have to have negative numbers because the middle is negative. If there's negatives anywhere over here, you're going to need some negatives in this list. The question is left side, right side, or both sides? Well, how are you going to make 30 with negatives on only one side? Like if I put negatives just down the little side here, I'd be doing something like that. And negative times positive is negative. I don't want negative. I want positive 30. Just like problem 1, you have to put negatives on everything here. And then hopefully you'll notice shortly that this is the correct combination. Why? Because negative 5 times negative 6 is 30, but negative 5 plus negative 6 is negative 11. So this problem is x minus 5 times x minus 6. Those are the binomials, and that was the process by which I discovered the correct combination, negative 5, negative 6. I'm not going to check my work on that one. Now, this problem 3 is different compared to problems 1 and 2. Both of these needed negatives, but they both ended with a positive. Here 20, here 30. And when I made my list, I put negatives everywhere. Well, look at problem 3. It ends with a negative 24. Okay, the numbers that multiply to make positive 24 are here. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. But if you're trying to make negative 24, you need negatives on one side only. Right? Because if I put them on the left and the right, I'd get negative times negative is positive. I need negatives on one side only. So here's the question. Should the negatives go on the little side, or should the negatives go on the big side? Little or big? The answer can be found here. Once you know that the negatives go on only one side, just look at the middle. Because there was a battle here. And after the battle, the positives won. Because they overwhelmed the negatives, because the negatives were smaller. So you put the negatives on the little side. Now, all these products or multiplications make negative 24, but only this combination helps you make positive 2 in the middle. So it's x minus 4, and it's x plus 6. If you put the negatives down the big side, you would not be able to make any kind of a negative or a positive number in the middle. Now, while we're at it, take a look at problem 4. It's got the same setup. It's got the x squared. It's got a positive number in the middle, and it ends with a negative. So this is exactly the list you want to use for problem 4, except instead of these two, you're going to pick the 3 and the 8, the negative 3 and the 8. This is going to factor like x minus 3 times x plus 8. Let's check our work again and make sure that this really is valid. So I distribute x times x times 8, negative 3 times x, and negative 3 times 8. And here's the totals. I get x squared here. I get 8 minus 3 is 5, positive 5, which is I wanted, and I get negative 24 on the end. So quite literally, these are the two numbers that help me multiply to make negative 24, but add to make positive 5. Now, this list worked great for problem 3, and it worked great for problem 4. And yet, if you look at problem 5 also ends with negative 24. That means you'll need these numbers, and it means you'll need negatives on just one side. But you'll never get negative 10 in the middle if you put the negatives on the little side. Remember I said there's always a battle in the middle. When you know that you need negatives on one side only, you've got to pick the correct side. And this time, the correct side is the big side. How do you know the negatives go on the big side? Well, if they go on only one side and the middle is negative, then the negatives have to go on the big side. And you'll quickly figure out that this is the combination that will multiply to make negative 24, but will add to make negative 10, because 2 plus negative 12 is negative 10. So I write x plus 2, and I write x minus 12. You might stop and ask, how do we know that we need negatives just on one side? Why did we not put them on both sides? Well, think about it. If I had negative on both sides, like here and here, negative times negative would make positive 24, and this thing would be, hopeless from the beginning. I look at number 6, and I'm thinking that this list will be good for problem 6 also. Right? Because I need a negative 24. So I need a mixture of positives and negatives in my factors. And the middle is negative, which means the negatives go on the big side. So study this carefully. All of these are going to make negative 24 when you multiply. But if you switch to addition, these two will help you make negative 23 in the middle. So this one factors as x plus 1, x minus 24. All right, sometimes instead of just going through and solving these problems one after the other, it's good to go through and convince yourself, where will the negatives go? And the answer is, there's choices. It's left side, right side, or both sides. How about this one? Where will the negatives go? The answer is both sides. You have to have negative times negative to get positive 40. Let's look at this one. Where will the negatives go? Not both sides, because it's negative times negative is positive. You want negative 40. So will the negatives go on the little side, or will they go on the big side? And the answer is the negatives will go on the little side, because the positive numbers must have been bigger and won the battle for the middle. Now, if that's too abstract, let me just go ahead and write down all the ways to multiply to make 40. Oh, I almost forgot. I was going to remind you again of how to get these numbers in case you don't remember. So, how I get numbers like that, I just go 40 divided by 1, 40 divided by 2, and I've already got 4 things to put on my list. 1 times 40, 2 times 20. Here's something you're not going to put in the list. You're not going to put 3 times 13-point garbage, are you? But you can put a 4 in the list, because 40 divided by 4 is 10, so your list will have 4 times 10. And the last thing in your list will be 40 divided by 5. 5 times 8 makes 40. So here's the list for 40. It's also the list for negative 40, with some slight modifications. 1 times 40, 2 times 20, 4 times 10, and 5 times 8. These will make 40. Put negatives on both sides, and they will also make 40. But if you want to get negative 40, you have to pick little side or big side. And the answer is, I want the big side to be positive, so that when it comes to that middle term, the positives will win the battle. I put the negatives on the little side, and I quickly grab this combination here, because 8 minus 5 is positive 3. You know what would happen if you had the negatives on this side instead? You'd get 5 minus 8 is negative 3, and you wouldn't match. Do you know what would happen if you put negatives on both sides? You'd never get negative 40. So yeah, you have to be pretty careful with this stuff, don't you? The answer is x minus 5 and x plus 8. Well, I think that about does it for today in this short video on factoring trinomials with negative signs included. I will say the only way we can make this harder is, and this is something else we've been avoiding, all of these problems have started with an x squared with no multiplier. There's no 5x squared or negative 2x squared. That raises the difficulty quite a bit, but we're not doing that today. Hope you learned something. Maybe you enjoyed it. My name's Eric. Have a good day.